This is part 5 of the second lecture of week 9. Here we discuss the second thing that you may have when you use the method of partial fractions. This is repeated linear factors. So what does it mean? If your function fs, this is some fraction which contains some polynomial in numerator, and in denominator it has a factor s minus r to the power m, where we assume that m is the highest power of this bracket s minus r in this factorization. In this case, this fraction can be expanded as follows. So something for these factors here and here, and the expansion corresponding to this bracket is the following. Say a1 over s minus r plus a2 over s minus r squared plus so on plus am over s minus r to the power m plus maybe some other fractions. So where the numbers a1, a2 and so on am, the numbers that you have to find in this expansion, and after you find this expansion, your inverse Laplace transform of this function f at a point t. Here we can use the, first of all, this formula and this formula. So for the first fraction here, a1, s minus r, this is e to the power at. In our case, a is equal to r, so e to the power rt. S minus r2 squared, we use this formula here for n is equal to 1. So this will be a2t because n is 1, and this displacement by r, s minus r, is represented by t to the rt by the theorem from the first lecture, and so on. And this term here, am, for this we use the same formula t to the n, but instead of n we will have m minus 1. So here s to the power n plus 1, so n plus 1 is equal to m, so m is n minus 1. So this here we obtain t to the power m minus 1, and also we'll have, here we have n factorial, right? N is m minus 1, so we have to divide here by m minus 1 factorial, and times also the term which corresponding to the displacement by r, e to the rt here. So we can check that if you find the Laplace transform of this term, you get exactly this am s minus r to the power m. Let's consider an example. For example, we need to find Laplace transform of this fraction. Let's for simplicity denote it by f of s. And f of s must be written as a s minus 1 plus b s minus 1 squared. These two fractions corresponding to this one bracket s minus 1 squared plus c to the power s plus over s plus 3. So this fraction corresponding to this s plus 3 factor in this denominator. So now we need to find a, b and c. Let's now use the second method that I explained in previous part of the lecture. In the second method, what we did, we multiplied everything by denominator to have s squared plus 9s plus 2 is equal to, here what we need, the s minus 1 times s plus 3. Here we have s plus 3, and here we have s minus 1 squared. So this is a times sorry, s plus 3 plus b times s plus 3 plus c times s minus 1 squared. So we obtain this expression, and now we take some values of s to find a, b, and c. Of course, the values to make some point zeros are s equals 1. In this case, we have on the left hand side 1 plus 9 plus 2, which is 12. And the coefficient of a is 0 now, coefficient of c is 0, and we have just coefficient of b, which is 4. So we find immediately b is 3. Then we take c is, s is minus 3. So the left hand side now is 9 minus 27 plus 2. So this is minus 16. And here we have the coefficient of a is 0 again, the coefficient of b is 0. Now the coefficient of c is non-zero. And here we obtain minus 3 minus 1, which is minus 4 squared is 16. So we obtain that c is minus 1. To find a, we need just some third value of s. Let's take maybe the simplest case. Let's take s to be 0. In this case, the left hand side is 2, and the right hand side is a times minus 3 plus 3b plus c. So when we substitute the values of b and c, we obtain 2 is minus 3a plus 9 minus 1. So 3a is 6. So sorry, 6. So a is 2. So it means that f of s now is 2 times 1 over s minus 1 plus 3 times 1 over s minus 1 squared and minus 1 over s plus 3. So using this expression now we can easily find the inverse Laplace transform of f at a point t, which is the first summon this, we use this line of the table. So this is 2e to the power t. For the second summon we use this one for n equals to 1. So 3 times t and times the displacement by 1, which is e to t, and minus 1 over s plus 3. This is again this line again, so with a is minus 3. So we get e to the power minus 3t. So this is the answer of the inverse Laplace transform for this function.